Hey guys, this is Priyanka joining you from Australia, and I am an AI MVP. I will be redelivering my talk today about closing the feedback loop, how to improve accuracy of agentic RAG with human in loop feedback. This talk was delivered at Microsoft Build, and I am happy that we are talking about this again. So let's jump into it. So, as you know, the agenda for the session would be closing the loop, feedback based learning for agents on Microsoft Agentic Framework. About me, so as you know, I'm a Microsoft AI MVP, work as an AI specialist at Avanade Australia, global speaker, author. You can connect with me on my LinkedIn handle, and I also run the Brisbane chapter for global AI community, and we run a very happening community here in Brisbane which is called as the AI Builders Brisbane. And coincidentally today we are also doing the build recap at Microsoft Brisbane under the AI Builders Brisbane meetup group. Jumping into the session, what before we talk about closing the loop and why we want this sort of a solution, let us look at why we develop this solution, for who we develop this solution, what are some of the current state challenges, and then we jump into how humans give feedback and how the system improves and how it learns and so on. All right. Okay, so here, as you can see, right now, and all those of you who had also been privy to build announcements or even prior to that Ignite announcements and so on and so forth, we have been hearing about agents everywhere, Copilot agents and Anthropic agents and Foundry, Microsoft Foundry agents and agent to agent protocols and so many other things, right? But there is no active learning for agents visible anywhere. By active learning, it means that agents that really work on their accuracy, learn from the feedback which is presented to them. So this kind of active learning and feedback based learning in production in enterprise grade systems is not so common. All right, so let us look at the problem we are trying to solve. So the system which we have built is an automation of the existing process for aviation systems. All right, and aviation systems have their own sort of protocol or own language. Think of like how banks have mainframes. So similarly, for airlines, they use an upstream system which is called as a global distribution system, or in short, a GDS. Okay, so this GDS system, it has this aggregation of real-time inventory of your airlines and hotels and car rentals, and they distribute this inventory to all the travel systems and travel agencies globally. All right, so since we are developing this solution for APAC standards and APAC region aviation systems, so which is why our GDS or global distribution system is called as Sabre, right? So then again, in Europe and in other regions, they use something which is called as Amadeus, Travelport, NDC, and so on and so forth. Okay, so think of these systems as having some command line interface where you can enter commands, like let's say enter a PNR number and you will be able to get information about PNR, enter some other command and you will be able to get updates of let's say what is the reissue policy, what is the cancellation policy, enter some other command and you will be able to request some extras on your ticket, like for example, I want an extra room space, I want to purchase extra luggage, so on and so forth. Okay, and airlines globally, they interact with their respective regional GDSs to be able to make bookings and retrieve bookings and then apply taxes and apply commissions and fares and reissues and cancellations and other things as well. Okay, and if any travel agency, like for example you imagine Agoda, or you imagine your booking.com, Trivago, all of these things, right? So if they work with these upstream systems and airlines, and they do something wrong, for example, imagine you are flying a United Airlines flight, right? And then your booking is via travel agency, Make My Trip or booking.com, that kind of a thing. And booking.com, because they are acting as the go between the agency, they ticket you wrongly, right? They apply some wrong taxes or wrong fares, or they oversee the reissue policy, and they make some errors in calculation. Then in that case, these travel agencies are issued something which is called as an ADM, okay, which is a debit memo, airline debit memo, which is like a penalty which is issued to your travel agencies, booking agencies, for their erroneous calculations. Okay, so now the solution which we are building, trying to prove out and trying to deploy these active learning agents in production, is for a process which is called as EMDA and S. Okay, do not get intimidated by the jargons. What it essentially means is, when we say EMD, it's electronic miscellaneous document. A is associated and S is standalone. Okay, and put in very simple layman terms, what it means is, when you have a ticket, right, next time you have a boarding pass, you carefully look at it. So when I book a ticket, maybe let's say it is, I want to travel from Brisbane to Sydney. Okay, and then that's it, I go to an agency, I ask them to book my ticket is booked. Now I might have a request on, hey, I want lounge access, right? Or hey, I want a vegan meal, or I want to have wheelchair assistance, or I want to have extra room space, I want to upgrade my cabin class, extra cabin luggage, extra check-in baggage, those kind of things. So these extra request, what we call it as ancillaries or air extras, these are categorized as associated with your ticket and then standalone. So anything that is your booking related, like as I said, right, cabin class upgrades and extra leg space and extra cabin luggage, extra check-in luggage, these kind of things are called as associated, right? So seat upgrade, excess baggage, and standalone are anything which are not directly related to your booking, but then they are extra services like special meals or wheelchair assistance, or you want to notify the airline that an unassisted minor is traveling, and you want to have some sort of oversight on that particular passenger. Okay, so these are what we are trying to build an agentic system for, right? So first of all, once you've understood the terminology, the dictionary for EMDA versus EMDS, right? So as we discussed that the A and S rules differ, and then there are multiple parties here, right? Like for example, there is this end user, there is this ticketing agency, then there is the airline, and there are these upstream systems, and different rules regarding airline policies and governance cycles. Okay, so let us look at how the current state systems operate with the knowledge that we have so far. All right. So today, what happens is, when this kind of an air extra request comes on a ticket, okay, so imagine, as I said, you have booked a ticket and now you have some sort of an extra request. So when this sort of an extra request comes to the travel agency which we are working with today, they have a team of around 140 people sitting offshore who are servicing these requests. So as you can see here, you have 150 offshore and onshore agents. They service close to 45,000 tickets for APAC region per month, and then on an average for a medium to complex booking, they take 10 minutes per ticket processing time. Okay, and why it is so time consuming and cumbersome and also manual and repetitive is because when such a request comes, one of these agents who's sitting offshore will be retrieving that booking, Okay, then he will be, when I say retrieve that booking, what they do is they actually go to the upstream systems, the GDS systems, they enter some command to with the PNR to get the booking. When the booking is retrieved, then they look at what sort of requests are these. Okay, then they try manually classify them as, oh, this is standalone, oh, this is an associated request. Okay, then if it is an associated or standalone request, they have to go to the airline policy pages. Then they have to look at those airline codes. For example, if I want a vegan special meal, maybe that service is not charged, that is free of cost. But how do I know that that is not free of cost? I have to go to the airline policy pages. I have to check the table of their codes where they have ascribed various codes to various services. And those codes will actually help to price the ticket accordingly, right? So they have to go to these tables, they have to look at these policies, and then accordingly fetch the codes, and then accordingly make the inference for the costing. Then they have to enter all those codes manually in another screen. This will price the ticket, and then it will invoice and issue the ticket as well. So all of these, as you can see, different interfaces, they have to open multiple applications, their own application where their own queuing system where they have made the bookings. Okay, then the aviation GDSS system, then the airline policy pages, and so on and so forth. And then there are no standard SOPs or SLAs described there. So if you're a veteran and you know all of these codes and all of these commands, it is easier for you to jump between systems. But if you are someone who's relatively newly onboarded, then imagine the amount of confusion and double checking and eyeball checking that has to be done to ensure that this process is smooth, and that you are not doing any error in issuance, and you're not getting any debit memo from the airlines for wrong ticketing. Okay, so these are the current state systems. And of course there is no reporting, like for example, what was the throughput per ticketer per day, or what was the average response time, or what was the most efficient ticketer, and are there any training gaps which we need to address to be able to bring all the ticketers up to a certain standard of performance. So no such kind of reporting, or what we say as a control tower kind of a view is available, right? So there's limited KPI and root cause analysis. Also sometimes there are errors where upstream systems are overloaded, so they might time out, they might just work after a few retries. So there's no SOPs of the standard technical errors and how these are handled and how these should be handled. Okay, so it's more of a guesswork, and I think on the job learning for current state systems and current state employees as well. All right, so keeping in mind all of these current state gaps and the problem statement, it's a classic case for agentic rehaul, right? So where we are agentifying these current state systems. So this is how our target state system looks like. Okay, so the same process happens, like a request comes, then the system validates whether it is an EMDA A or S type of ticket, then it does the process validation, and then it goes to the other steps of issuance and invoicing, right? So instead of the humans here, as you can see, manually picking up the tickets and then manually looking at the masks and doing what they need to, these are replaced by agents. Okay, so we have a triage agent that is going to look at the booking, and then it will determine whether this is what kind of ticket is this, right? Is it is a reissue, is a new request, is a cancellation, those kind of things. So that is the triage. The triage agent will determine what is that request about. Okay, and it will also retrieve the PNR details, the booking details. Then we have the mass check agent that will do the mass checking, which means determining whether this is an A versus S type of ticket. Okay, if it is an EMDS, where it is standalone, where you have some comments from the agency like unassisted minor or wheelchair assistance, return in some comment field, or return in some sort of shorthand airline terminology, then the agents meaning the AI agents or the Microsoft Agentic framework agents, they will read that comment, they will infer it, then they will go to the airline policy pages, okay, articles, and then they will try to match the cryptic comment or the shorthand comment with the airline documentation. They will fetch the codes for pricing the ticket accordingly, the pricing the service, right, like the standalone service, whether it is a pet in cabin or wheelchair assistance or unassisted minor or group booking or some sort of ancillary fees, those kind of things. It will basis the comment, it will go and it will compare it with the airline policies, procedures. If it is unsure for any for any matter, right, whether it is unsure that it has may not made the correct inference or it has not fetched the correct codes for pricing, this will flag it to a human agent. Okay, the human agent will then come in, it will review the AI's inference, then it will either the human agent will accept or will update the AI fetched values, where the AI will remember, right? So for the next time similar thing happens, the AI will be able to remember and AI will be able to take accordingly correct decision next time onwards, where this active learning and feedback learning comes into picture. Okay, so for the first time, if the AI is unsure, we have configured a threshold value there, right, some sort of confidence threshold. So if it falls below that confidence threshold, it will be tagged to the human agent. The human agent will be able to provide feedback accordingly and then proceed, right? And then we have a battery of your horizontal cross cutting agents for monitoring, for test cases generation, test data generation, governance, and for admin purposes as well. Okay, so if you look at the multi agentic architecture with Microsoft Agentic framework and the Azure ecosystem, you have your infrastructure which is all Azure native. So you have APM and application insights and Azure monitor and log analytics, and purview for governance. Okay, then you will have also a defender services turned on both for your AI and your Azure services, right? Then you will have AI search, where we are storing all the airline policies, airline related policies and procedure documents. We will have reporting data, which we will store in PostgreSQL database for control tower purposes, KPIs, throughput monitoring, error reports, and such. Um, you'll have your vector database again, which is Azure AI search. Then we'll have the raw data sources, which are airline websites and other analytic logs. Okay, and you will have that will form your data layer. And then you will have your agents, as I said, like you'll have different um, series of agents for your feedback process, for your master data management, notification, validation, checklist, invoicing. You will have agent related tools, where these agents are connecting with the upstream systems for authentication, for PII redaction, for memory management. And then you'll of course have your shared microservices, which are your Azure AI services, which are your other tools for agent as well as the data management. Okay, and then you have your marketplace tools, which is your Foundry, IQ, then your knowledge bases and your MCP protocol connections or MCP connectivity to various other ecosystems or various other platforms as well. Okay, and then you are using your application layer, which is nothing but just a React interface, right? Your model serving is in Microsoft Foundry, so we are using the Foundry hosted agents, and yeah, we are using the code first pattern, so using SDKs, Foundry service SDK, to create and host the agents in Foundry. Okay, and they are all governed and operated using Microsoft Foundry native telemetry, monitoring, evaluation services and SDKs. All of this is code first. Nothing is directly from the portal, because we are deploying this as enterprise ready systems. All right, but using Foundry SDKs and using the Microsoft Agentic framework for orchestration has been very seamless for us. In fact, we are going to go live to production in the next couple of weeks. We are right now in the user acceptance testing phase for this particular system. All right. So as you can see, the target state architecture is actually showing you all of the different data exchanges that is happening. Every single call and every API call is gated via APIM. Logic apps forms our orchestration mechanism. So a queue, a ticket or a request comes in a queue, then in an event hub. Okay. And then from the event hub, you can see that, it is picked up by logic apps. The logic apps will then orchestrate the various agents here, whether it is a triage agent or whether it is the mass checking agent, and it is the main orchestrator agent, and so on. Okay. And we are using AI search for the RAG retrieval for those special, EMDS related requests. Then we will have your foundry models. We will have data ingestion pipelines to be able to chunk and embed the airline policies inside of AI search, right? And then we'll have the reporting mechanism. There will be orchestration mechanism using human in loop feedback for unsure or for below confidence threshold inferences. And on top of that, there will be reporting as well. Okay. So enough of talk. Let us look at a working demo covering all of these concepts which we have just seen. All right. So this is how a UI will look like to an end user. So as you can see, you will have whatever the PNRs are queued for action, they will be available in this screen, right? So any request when it comes to the queue is first picked up by the logic apps and then subsequently given to the AI agents, the Microsoft Foundry hosted agent. So as you can see, I already have 2 tickets in processing here, right? Okay. So and these are different airline systems as well. Okay. So we are already seeing that whenever a ticket comes in, it will start the agents themselves will start processing those tickets. Now if the agents, and then this is a live process ongoing where it is trying to fetch the booking, it is trying to verify the booking details and then the masks and so on and so forth. Okay. So now interestingly look at this particular ticket, for example. Okay. So in this ticket, it has been, the agent has gone through till the point where it has looked at the other info field which is input by the travel agency person. So you can see that this is called as loyalty memberships. Yeah. And then it has looked at the operating flight which is Qantas. Okay. So then it has gone to our AI search database. It has looked up the Qantas related airline policy procedure articles. It has looked at loyalty memberships inside that to look at the code, right? What we call it as RFIC and RFISC codes. These codes will be used for pricing the service, whether it's a free service, whether it's a paid service. So what are the taxes and so on and so forth. Okay. So then it has found something, like it has found that it's an ancillary service, and potentially these are the codes which will be used for pricing the service as a per the Azure AI search RAG search, right? And it has also given me the metrics: accuracy 28, consistency, coherence. Okay. And it has still tagged this. So see, you can see that needs a item to proceed. So this is tagged it for human in loop, is because as you can see, the accuracy threshold it has fetched is quite low. Now it could be the fact that it was still right, like even with low accuracy, as you can see, consistency and groundedness are quite high. So this could be still okay, right? Or this could be genuinely incorrect and I will have to change the code. So me as a human specialist have come in, I have looked at this and I have now decided that, hey, no, the code is wrong. Okay. And now when I'm clicking on build A here, you see that the correction is recorded, and then I can give an optional feedback here, like for example, the correct code for this is ABC, whatever that is, right, is F, because this is a member related service. Okay. So I have given some feedback as well, some pointers to point my AI in the right direction, right? So here I have given some feedback, and then I confirm build. Okay, and then now I can send the PNR for further processing. So now I can, send it for further processing, and it will then, go into the same state as this, right? Okay. So now if you see here, I'm simulating a send PNR action, right? So here I have created a new PNR, right? So here, now that new PNR, if it is going through the same situation, as you can see that, the loyalty memberships, and what requires to be done here, right? So this time around, actually the A and QFF values were correct. I overrode the previous one, right? I overrode it with F. Okay, so it has recorded the correction once. Okay, but it knows that, when it is doing the AI search, it knows that the values it has found in the tables are some of these values. Okay, so it will not just accept your correction at face value, because it would be, tantamount to kind of misleading the systems as well. So it will do a balance of what it is factually finding versus how many amount of corrections are happening. So with just one correction, unless it is, outrightly wrong, and it is outrightly, it knows that it is not able to find and it is not able to infer correctly, so it will do the balance of your end correction versus what it is finding in the corpus, right? Even with low confidence thresholds. So when this correction is next time made, it will remember that decision, and it will go and it will look at, should I accept your correction for the next time some similar scenario occurs, or should I still flag it for human in loop and allow you to still correct my inaccuracies. That is a way for it to balance its own inferences versus what it is being taught, right? Okay, so not just accepting historical corrections at face values, but striking that balance of actually fetching something versus correcting it over a period of time as well. All right, so this is our human in loop process and accuracy gating process. We are using, your agent memory stores to be able to record these corrections, and then take a weighted decision on whether it should go by the historical feedback provided, or it should still, tag it for human in loop with the values which it has found in the corpus, and then decide the course of correction and course correction over a period of time when the same repeated feedback comes in from different users, not just the same user, right? As I said, we are avoiding mistraining of the system as well, with unintentional or intentional wrong feedback. Okay, so here also you'll be able to see that we have, agents where we are able to chat. Okay, so admin agent is where we will be able to ask about, hey, what are the defined KPIs for this process, and what are the agents in action, and what does a triage agent do, what is the meaning of EMDA and EMDS. So all of the vocabulary and all of the airline related questions we can ask to the admin agent. Processing agent, we can actually ask questions around your KPIs, or explain why this failed, or explain why something is not working, and what is the reason for more SLA breached PNRs today. Like for example, if we have SLAs defined that it should take 1 minute for EMDA kind of tickets and 2 minutes for EMDS kind of tickets, but imagine there's a complex booking, right? So it's a group booking and it has 15 passengers, because you are all booked as a one big family in one single PNR. So in that case, it might happen that it has to go through multiple request for multiple passengers, and it might take some time. So then I can ask that, hey, why this particular PNR has breached my SLA of 2 minutes, and then your processing agent will be able to query your logs, which we are logging everything, like every single thing that is happening. PNR arrives and which agent picks it up, which MCP tool is invoked, and what happens and which model is invoked. All of that is getting logged in the database in PostgreSQL, and also using your Azure monitoring services ecosystem as well. So all of that is logged, and we are then able to query the processing agent with the help of our. So for example, if I say, what are the uh, uh, tra- travelers for PNR H4 H4038. Okay, so I will be able to ask questions like this. Okay, and then it will be, going back to the PostgreSQL database, and it is NLP to SQL, so another agent which we have built, where it will be querying the logs, and it will be able to, find the travelers, convert this query, NLP query into SQL, run it against the PostgreSQL database, and then be able to show you. So because this is a live processing system, so maybe, the logs are not yet generated there, so it is showing you something went wrong, but then nonetheless you get the idea as well, right? And then we have an entire reporting tab for the ticketers to be able to actually look at the data, right? So throughput, completion times, what are the error rates, what are the AI versus human corrections. So as you can see, error rate is 30%, and there are throughput, and because this is a system being in test, you can see that average completion time is a bit way off. But yeah, so you will be looking at this is a very interesting metric, the human corrected versus matched AI, and that will actually give you an idea of the system as it processes, right? As it whether the accuracy is improving over time or not. So if you see, over a period of time, this human corrected pi should decrease and the matched AI pi should keep on increasing, right? So the AI is making the correct decisions, and the human corrections are few and far between. All right, you'll also be able to see the operations, where you are able to see the end-to-end completion times, then what the ticket assignment, what is the classification of errors, like you will be able to see what are most of the common errors happening, or what are the common technical glitches happening. You're also given a view into the quality. Okay, so for example, what were the PNRs which were tagged as ADM, like it resulted in wrong ticketing, versus what were the PNR which required human in loop and which actually required a correction and feedback from humans. Okay, and then you will also have a view of AI governance, where you will be able to see the governance metrics, and what was the average consistency, coherence, and again same, the human corrected versus AI matched values and exceptions, is where you'll be able to see all the SLA breaches, any feedback which was given on some of the PNRs, and you have various slice and dice ranges as well. All right, so that concludes our agentic feedback of and learning active learning systems for today. Thank you for joining me, and I hope you have at least a glimpse into how active feedback based learning systems are developed and deployed in production. Thank you so much.